Um, Hello, everyone, and welcome to our seminar for this month. Today, we are excited to be joined by Dr. Marcy Fadai. She's going to talk about building better language models through global understanding. So a little bit about Marcy. She is a staff research scientist at Cohere Labs, where she focuses on advancing multilingual NLP and language models. She co-leads the AYA initiatives, which produce the largest multilingual instruction datasets and suite of state-of-the-art models. Previously, Marcy led NLP stroke machine learning research at Zeta Alpha Vector. She holds a PhD from the University of Amsterdam. I think this is going to be quite an interesting talk. I'm looking forward in the age of large language models and, their representation for like global languages. So Marcy, over to you. And yeah, let's just give Marcy 1 minute to share her screen and then she'll start.
Yeah, hi everyone. Thanks for having me. Very excited for this session. I hope you can see my slides and everything looks good.
Yes.
So yeah, today I want to talk about why it's important working on multilingual problems and what are the challenges and like how we can address them, how we have been addressing them so far. And as Millicent actually mentioned in her really nice introduction, I have been working as part of my research in the past 2 years on the AYA initiative. So that actually started in 2023 with the collection of data and training of the model. But the release of the first model, the AYA model, which supports 101 languages, was February last year. As well as the data sets that we collected for covering around 130 languages. And then since then, we have been working on building better multilingual models, which ended up one release that we did last year in October was the AYA Expanse model, which was the state-of-the-art multilingual model at the time. As we know, things also change very rapidly in this field. And then more recently, earlier this year, we released the multimodal version of the model. So the AYA Vision, which has image understanding, but also supports multilingually for a set of languages. And I start by this just to share that throughout this journey of building these multilingual models, and also like previously during my PhD, I have worked with multilingual problems for a long time. And today what I want to talk about is, first of all, why it's important, why I think it's important to continue working on these problems. And then next, I want to talk about what might be still missing, especially more on the methodological foundations and not necessarily only the data part, which we know would be really like a bottleneck for multilingual learning. And then lastly, I want to focus on new ways and new territories to explore, in particular with the lens of evaluation. So I think this room is a quite diverse room. I don't really have to justify this, but the world is a big place, a diverse place. And there are many languages, many people that speak different languages. And it's really a pity that with this technology that we have, the language models in particular, that it might not be accessible to everyone in the world. When we look at how research is done in the multilingual setting in particular, we also see that it's not always that not every language is treated equally by researchers. So even when researchers focus on multilingual problems, it really depends on a lot of factors, and it's not always, it might be disproportionate to the the number of people that speak that language, which means the number of people that will be affected or have access to a technology that has been built for that language. And one good reason for that is that the data bottleneck, like I mentioned. So for building many of these models, we work with internet data, and it's predominantly English because it's the universal language that we all speak, and also the early users of the internet were English speakers, and the distribution of documents and text on the web actually follows the distribution of the early adapters and not necessarily the real distribution of number of people in the world. And as a result, there are a lot of languages that are under-resourced. So there are not enough really data to learn really good models for many languages. And this long tail problem, this impacts different languages differently. So when we talk about multilinguality and low resource and high resource, it's also like per language, it is very different, and it's a unique case for each language. And lack of data is one problem, but also like the quality of data is another bottleneck. So for many of the long tail of languages, even when you have data available on the web to use to train language models, the quality might not be there. So all of these to say how where we are today, models are great and at English, they are okay at a few languages, but there are still a long way to go to have like a really good universal support and performance for a large number of languages in the world. And I talk about really from like the user perspective, so like why it's important, like the user access to this technology. But now I want to also take a little bit of a journey to the past, recent past, on for another reason why I think it's important to work on multilingual problems. And the main reason is that actually where we are today with this technology was built on research in multilinguality. Or actually how in the past 10 years, the models that we have, the generative models, went from generating sentences like the above example to generating super fluent sentences and text that we have now. And this journey starts in the machine translation field. When you look at the history of different approaches to machine translation, there have been like decades that at some point rule-based MT systems, then for a short period there were this like example-based, and then for a long time until 2014, statistical machine translation was the approach to address the multilingual problem of translation. And then in 2014, it started to change. It also, end of 2014 is also when I started doing my PhD on machine translation. So I went through this journey very personally myself. And like I said, before that, it was just statistical MT. And there were language models used at the time. But how we were using language models were to add a factor to get more fluent generation, more fluent translations essentially. So no neural models, only a n-gram-based statistical score that would be added to the equation to have and to balance also with the accuracy of translation. So this, like the language model would bring in fluency to the translations. And language models, actually large language models, technically have been around also for a while, but not neural models. What happened in 2014, there were a few papers, I think maybe many of you are familiar, that changed the paradigm of the machine translation field, and then later on every other area. And the first paper was the paper by Cho and collaborators on using a recurrent neural network for translation. So they showed that this was one of the first times that a neural model would be used in an NLP task. They evaluated on machine translation. It was okay, but still way behind statistical approaches. Later that year, another paper came out by Elias Suskever and collaborators that also looked at RNNs, but in a different setup. So previously, they used it as just an additional score, but here it was like a fully generative model for translation task. Still, quality was okay, but not the best. Like the best result was still the statistical model. Again, continuing 2014, the first paper with adding a global attention to the RNN also came out. And this was really like just bringing this new form of thinking of you don't need to compress your whole input sentence into just one representation, but you can actually have points of just touching during the generation part, which was the first form in the form of global attention. Later on, 2015, a paper on combining global and local attention, still with the RNN architecture came out. All of them still, the task is evaluation on machine translation and really trying to solve the translation problem. In the same year, the byte per encoding paper also came out. So a new way to tokenize rather than just like word-based tokenization, a new way to have split words into subwords based on how often they occur in your corpus, which would actually help for the models not to generate Ankh tokens and be able to generalize well to tokens that they also haven't seen during training. And then 2017, the transformer paper came out. And this was one of the really, even before that, it was very clear that machine translation has been moving on from statistical models to neural models. But this really cemented the influence of and the significance of neural models for translations, in particular, for the task of multilingual learning of language. And I think there's a good lesson here. When we are looking at multilingual problems, they are very difficult. They are definitely not easy. But when we are trying to solve multilingual problems, that's actually where a lot of the innovations can happen because of how difficult the problems are. So to wrap up the first part of my talk, I want the takeaway to be that it is important to work on multilingual problems. First of all, for people to have access to this technology, but also because it's a super hard, complex problem that would require sophisticated solutions. And it's not really about just like being good for the humanity, but also like it can help with building better, more generalizable models. Okay, now let's dive a little bit deeper into when we talk about building a model. One of the questions that come up when we build a language model is the question of evaluation. So when also like in this same for like building a multilingual model. So oftentimes we want to see, okay, which model is actually the best. And when we talk about evaluation, there are a few characteristics that every evaluation should have. So evaluation should be fair, transparent, representative, and robust. But when we talk about evaluation in the age of language models and how the current way that everyone is doing things, how is it actually fair to compare models of different sizes, different training data, different decoding methods, and in particular for multilinguality, when they have different coverage of different languages? Also, when we talk about transparency, just how often are the conditions of evaluation really clear and shared? Are we sure there are no data leakage? What are the details of the training and the inference that we do in, and do we share those details when we publish the work? And when we talk about representativeness, it's really thinking about what is it that our evaluation is measuring. Is it representing, who is it representing? Is it the user interest? Who are the users? Or how, if in the context of multilinguality, how often do we actually have really culturally relevant questions in our evaluation? How can we, are we measuring cultural nuances per language or not? And then lastly, when we talk about robustness of evaluation, of course, we want the evaluation to be replicable. We want to really test whether the gains that we see are significant or not. And also like how cross-lingually robust it is, and how can we trust, how much can we trust the evaluation numbers when we evaluate multilingual models? And you would think that these are really maybe like, it should be really basic questions that we should all agree on, but it's very difficult kind of in nowadays, because not every two model is really the same in a lot of the details. So when you, for instance, look at the very recent open source language models, we see that the language, the number of languages they cover is different. For some of them, we, like Gemma, we also don't really have the list of languages. And there are also like different variations in the training. We don't really know about their data. So what is really a fair comparison in this setup? And it becomes even more confusing when we look at how the evaluation currently looks like. So here's a fun example of the Gemma 2 and Llama 3 technical report papers. And in each paper, they compare their own performance with the other one. And you expect to have the same number on the same evaluation set, but we actually have different numbers, both for themselves and also for the other models. So it's really hard. And the main reason is that there's a lot that goes into really what is this number in the end that we have. All of the details of whether it was like, in this case, like for instance, like chain of thought was used or not, like 0-shot versus 5-shot, the temperature, or like all of these details, shared or not shared, can influence the final number. So evaluation, especially multilingual evaluation, currently is really not as straightforward as one might think. So I want to briefly, in this part of my talk, talk about some of these maybe like fun inconsistencies in evaluation that we published recently, and we are presenting this work at the COM conference later this year. And one was looking at actually at when we are, so a lot of times evaluation sets are, for multilingual problems, they are translated. So usually there's like an English evaluation set, and you would translate that to different languages, and that becomes your multilingual eval set. And the first question here is, does the translation quality and where the eval data come from has an impact on the result of the evaluation. And we see that, yes, by a huge amount. So depending on, so here we looked at translating an English evaluation set with 4 different translation models. So the, sorry, are there any questions? Okay, maybe
no questions.
Yeah, okay. Like NLLB, Google Translate, the AYA model, and Command A model. And we see that the change in win rate, so ideally we want like 0 change, right? We want, if you are evaluating model X on an evaluation set in Arabic that was translated from like using NLLB versus like AYA model, we want really no change at all. Like because the model shouldn't be, but what we see is a big change. So the translation quality of the eval set per language and also per translation model has a huge impact on which model would be like the change in win rate. So which model is better than the other one. Another point to think about in multilingual eval is how we aggregate the results. So a lot of times, for kind of also good reasons, so like big tables, if we report per language, per task results, is going to be really not readable and also really hard to come to conclusions from. So usually what we do is aggregation of numbers, some sort of averaging or weighted averaging. And here we looked at how, depending on what you are aggregating and how you're aggregating, the rankings of the models can actually change. So here we looked at the European leaderboard and 5 different models on that leaderboard. And there you see the default rankings of these models. And in particular, if we look at the Mixtral, the mixture of expert model from Mistral, we see that it's on average second, but then if we only look at MMLU, it will be first, so it will go up. If we aggregate high resource languages, on average, it's still second. If we aggregate medium resource languages, it will go down to 3. And if we aggregate low resource languages, it will go down to 4. Why does this matter? So like I said, aggregation is not, it's kind of inevitable to come to conclusions. But what's important is when someone wants to use these models and how they decide on what model they use. I think that is the part that is really important. So for instance, if your use case is for languages that maybe fall into the low resource one, the low resource category, maybe the model that is on top of a leaderboard that is like an average of everything might not be the best choice for you. So really reporting detailed and individual evaluation numbers is really important. And then in our selection, looking at these detailed and individual numbers would be our recommendation for picking the best model for each use case. Another aspect that we looked at in this paper was how per language things can be different. So another view for like so let's say like we talked about the problem of aggregation. So then next is, okay, so if we don't aggregate, if we look at the individual languages, we do see usually a large difference between how models perform in different languages. And an important thing to think about is in this part is how significant is like when your model is really like the best, or like you want to get your model to be performing the best, how significant are these changes that we see? And one interesting finding that we saw was that it's really like the significance of differences depends really on the size of the test sets. I think that's not surprising. So with smaller test sets, it's really, the changes are not maybe that meaningful and significant, and also the language. But why this might be skipping our mind in nowadays setup? Because a lot of evaluation sets, when you see like a multilingual eval set, it's really like nice and pretty, and it covers a lot of languages. It's huge, but then you look at like per language, and sometimes for good reason, because also like the data is not is scarce, but the size of the data that you have in your eval per language might be quite small. So if you have like a language, an eval set with like 1,000 size, like that is a decent size for eval. But if it's multilingual and then per language you have 100 samples, or sometimes even less, how meaningful is the performance that you are getting for that language? So that is something that is really important to consider when you want to run evaluation. And another topic we looked at in this work was now if we have language models as the judge. So in a lot of setups, especially for evaluating open-ended generation, we use language models to judge the generations. And in this experiment, we saw that there was actually, so we tried like a few different models as a judge, and then see how well they correlate with human preference and also with each other. And we saw that there is no single judge that is best across all languages. And by the way, these are still, like, we are not really in the low resource language setup. Like, these are decently sourced languages that we expect the models, and the models are kind of like officially or almost officially, they support these languages. But even for this set of languages, we see a huge variation in performance between models as a judge. And different models are, so for instance, like GPT-4 Turbo was the best judge in 5 languages. Command A was the best judge in 6 languages. So it really varies across the board. So to wrap up the second part of my talk, I think it's really important, and I want to emphasize again how with evaluation, it's kind of becoming a little bit tricky, especially with multilingual eval, because of really not having more options. But even in the setup that we don't really have more options, we can definitely do better by, so even if the eval sets are not perfect and like the coverage of language is not great, we can and we should do better by doing a more systematic and scientific practice of evaluation. So reporting, for instance, all of the details of how we are from the prompt to the hyperparameters to every detail that was used to run one evaluation, reporting significant testing, per language reporting, so not only reporting aggregation results. So these are really important to really do good science and be able to build on top of each other's work. Right, so in the last part of my talk, I now want to, I think so far maybe it was a little bit like grumpy, really looking at, okay, what are we maybe not doing that great, or like we should be doing better or pay attention to. But now I want to look a little bit into the future and what we should be thinking about, what we should be working on, in particular for multilingual development of multilingual models. And one area that I think is very important is multilingual evaluation. So for really good reason, evaluation really enables and leads progress. So for anyone to actually wanting and willing to work on a problem, they do need to have an evaluation, a metric, something to measure their progress, like how well they are doing, how far away they are from where they want to be. And if we want for everyone in the research community and beyond to work on multilingual problems, building representative, interesting, and nice evaluation sets in these languages would be the first step to do that. And there's a good reason why it's not done a lot, and there's a good reason for that, because it's very difficult. So you need really attention and knowledge of cultural nuances when your task is to build evaluation sets for different languages. So this was an interesting study that we did. We looked at the MMLU data set, which is like a multi-choice question answering general knowledge, very common that everyone uses and report numbers on. There are different topics in this benchmark, and we ask human annotators how much they agree or disagree with the answers once the question answers are also translated into their language. So essentially, the question was, can we translate MMLU into a different language and use that for evaluation of that language? And what we saw was that for a lot of STEM topics like mathematics, computer science, algebra, there were a high agreement between so the annotators agreed with the correct answer in their language. But for the topics that we had a high number of disagreements, they were actually more on this like a social side, like the history, law, philosophy. So this was a clear indicator that translation alone wouldn't really capture everything that we would like in a multilingual benchmark. And we with more analysis of the MMLU benchmark, we collected this label of like how many of the questions are culturally sensitive versus culturally agnostic. So 2 + 2 = 4 is a very like culturally agnostic question, but a particular question about maybe like a mountain somewhere in the US, like you need like some geography knowledge of that part, or like history knowledge, things like that would be culturally sensitive. And we saw that a huge number of 28% of MMLU is actually culturally sensitive. And out of this 28%, a huge portion of that, around 86%, is no surprise Western focused and English and US focused. So what we decided to do in this work was to build global MMLU with this knowledge and this really knowing this problem. So as part of this work, we also did this study. The goal was to translate MMLU to, I think, 40-something languages. And then what we ended up doing was adding this label of culturally sensitive versus agnostic, as well as using human annotators to do post-edits of the translation. So this data set would become really a good representation of a kind of like a word knowledge that is still relevant for different languages in different cultures, and is currently now used in many works that work on building multilingual language models. It was also really exciting that in the Stanford AI Index report this year, they reported this as one of the most influential data set releases of the year, which is, super exciting. And we actually saw that performances would be different when you look, and the rankings of the model, when you look at the cultural agnostic subset of this data set versus when you look at culturally sensitive part, which is kind of expected. But if we look at the global MMLU or like the MML, like a translated version of MMLU, and then look at one ranking of the models, we are not really able to capture these differences and nuances. And yeah, so here's just more examples of how in each language, like the rankings of the models would be different in the culturally agnostic versus sensitive part. So what we did in the global MMLU was to build this kind of like an apple to apple per language, the same question in different languages benchmark. Next, in a project called Include, we complemented that benchmark with in-language, with an in-language benchmark, essentially. So instead of translating existing English benchmarks, we set out to collect and build this massively multilingual source of questions and answers, multi-choice questions in different languages. So really like in the original language. And in particular, we focus on topics that would also result in really like interesting differences. So for instance, like art and humanities, like you can imagine like the university exams about art or history in different countries with different languages would cover probably like a lot of different and more local questions. And this benchmark is also, it covers 44 languages, and it's released. One thing to note is that because the exams are different in different languages, performance per language is not really comparable expectedly. So our suggestion is to use both global MMLU and Include because each capture different parts of assessing the performance of a model. And next, we very naturally, the next thing that we did was to build a similar data set, but for multimodals, for understanding image component as well. So a lot of times questions, if they come with an image, whether it's like a graph, like a physics diagram, or like photo of a place or a map, you need to, like for a model, part of the context of the question would be in the image. And in this work, it was really important for us hope is that with all of these new benchmarks, people will work even more on these problems. And then lastly, we, as part of the IOVision release, we also released the IOVision bench and the multilingual white vision benchmark. So there are for open-ended multimodal image understanding, open-ended generation eval. And yeah, it's really exciting as these models are becoming, like multilingual models are becoming more and more stronger, add modality. Hopefully these would be really a good stepping stone for people to work on these research problems. And yeah, so I want to wrap up here by saying that I think it's really important if we are thinking about with the technology that we are building today, we want to capture intelligence and knowledge. It should also have cultural understanding, and we need to add what we mean by this to the existing narrative of building the models. And one very fun and important part is building evaluation sets so that we can measure these capabilities and have models that hopefully can be used also by a lot of people around the world. Right, so I want to wrap up, and we have a good amount of time for questions as well by summarizing my one, why it's important to solve really like complex, challenging problems. You also contribute to better modeling of the human intelligence. And it's when in the process of building this, we need to be really more disciplined in how we do evaluation and follow rigorous frameworks so that we are also like true to our really like our commitment to good science. And lastly, it's very important if we are working on multilingual problems to also include people in the process of building these models. So that can only happen by global collaboration and really continuously updating all of our frameworks and benchmarks that we have so that we can capture all of these nuances in different languages, in different cultures around the world. Yeah, that's it for my talk. Thanks for listening, and I look forward to your questions.
That was quite an interesting talk, and so exciting and quite informative, Marcy. Thank you very, very much. We have a number of questions on the chat, but I think Danlami, your hand is up, and I wonder if you want to go as I read the other questions.
Yes, thank you, Millicent, for giving me this privilege to ask this question. Good afternoon here from Nairobi, Mazi. That was a very good presentation. I must commend you for that, especially given the fact that the challenges has always been in the area of evaluation, considering that we have a plethora of metrics we could use, but still there is need to kind of innovate or bring up some ideas of how to sort of do this evaluation that could have some kind of human at a human level. But my question now is this: I saw from your presentation, some of the models you presented here, open source, as you've rightly said, but I'm worried with the architecture because like Llama now, Llama is supposed to be a sequence to sequence, which is an encoder-decoder, right? Quen and German and the rest, I'm not sure if they are sequence to sequence. So if there are no sequence to sequence, is it fair to sort of have that kind of comparison between a decoder-only architecture and encoder-decoder architecture?
Yeah, that's thanks for the kind words, and that's a good question. So architecture is another aspect. When I mentioned earlier, like the differences between all of these models, that can also be like part of that. Whether it is fair or not, it's really hard to tell like which one would be at an advantage sometimes, because it's not the only factor that will contribute. I would probably argue that like the data and the tasks they were trained on, that might have a more influence on performance than between these two architectures, but that can definitely be also a contributing factor. And that's why it makes it really hard to say, like nowadays when we compare different models. The thing is, I also don't really have a solution for that. Like the models are different for different reasons. I think the important thing that we can do is just be aware of this and raise this awareness. So when so if we boil down evaluation to one number and one leaderboard and one ranking, it's really not at all capturing your specific like use case and your preference. So knowing that and studying this more, I think that's more important. Yeah, the question of like fair evaluation, it's a big one.
All right. Thank you very much. I really appreciate it.
Yeah, thank you.
Yeah, so Marcy, Omar is asking, since Arabic has a huge corpus of text created for like hundreds of years, is there an initiative to train, Arabic LLM, a standalone one?
Yeah, that's a very good question. So I actually don't speak Arabic. I think in terms of like knowing like how well the current Arabic models are, but what I do know is that for Arabic in particular, there are many different dialects that might be, some might be more similar, but some might be actually very different. So even when it's like one language and it might seem that there are like a lot of people speaking that language, when you look at these details, like it becomes really, it's not as straightforward as just building a model for that. That said, there are efforts on, so I think there are like 10 Arabic models released by, I'm not sure, I have to check. But also like at Cohere, we did release earlier this year, so we have the command model, which is a multilingual model, but we released the command Arabic model, which has been like fine-tuned and like an expert for the Arabic language. So like that's also something that you can check out. So there are some models out there that focus on the Arabic. But yeah, definitely still a lot of room for improvement as well.
Thanks a lot, Mazi. Antonis, would you please just, ask your question? It's quite an interesting one.
Yes, sure. Hey, hi, Marcy. Thanks a lot for the talk. Great talk. So I found this analysis that you did on MMOU very interesting, and I see you defined cultural sensitivity of each question. So I'm really wondering, how did you define this metric? Does it have to do with translating the same question across languages and measuring performance of models, or how did you come to this metric?
This was a human annotation job. So we ask annotators to label whether a question is culturally sensitive or agnostic, and then in the guidelines, we did that like for different languages. So translation, depending on the annotators that we had, like we covered a set of languages, and in the guidelines we had a few examples and also just really like defining what we mean by culturally sensitive. I think in the paper, in the appendix, the full guideline should be there. But when we talk about like culturally sensitive, what we were interested in essentially was that asking the annotator whether you need some knowledge from a different country or a different culture or a different language to answer that question. So like a question about the US election or some details of constitution, like that definitely needs you to know that knowledge, or like geography or art, like movies, TV shows, like things like that. And maybe for all of us, the US culture might be a lot more dominant. Like we all probably know like a lot of TV shows and movies from US. But a good example is actually using just thinking about like another country. So let's say like I speak Persian. So if there's like a question about like a Persian movie, like you do need to have like that sort of knowledge. So with this guideline and working with the annotators, we collected this label for the questions.
And maybe a small follow-up question based on that. So across those questions that are like more culturally sensitive, let's say, do you think that most of the knowledge that you need there is sort of, let's call it factual? So is it about specific specific facts regarding a country or a geography or something like that? Or were those also language nuances? So for instance, that the language would be used differently in one country versus the other?
It was mostly, if not 100% factual, like yeah, it was more about the knowledge. If there was like a problem in, or like if there was something about the nuances of the language, it was mainly because of like a translation artifact. So we also asked the annotators to do post-editing if something was weird or like didn't look right. But the question of, yeah, it was mainly like the point that they would disagree was the knowledge, the factual knowledge part.
Great, thank you.
Yeah, thanks. There was like a subset, so it depending on the top. So I think there was like a moral studies subset, like that maybe it's a more gray area, like whether it was like a factual versus like the type of questions might have been like a little bit more, but for the most part it was factual. Yeah.
Mm. Thank you.
Right. Yeah, Kevin also has another question here. He's saying he's working on multilingual on the Kenyan context and have managed to fine-tune, models for Swahili using local open source data, and is worried that the current metrics may not reflect the state on the ground, as it's going to go even to more, local languages. I think you have a map of like resource, low resource, and extremely low resource. So this will fall under extremely, extremely low resource. These are Kamba, Luo, Kikuyu. These are languages that are spoken within different ethnic communities here in Kenya. So what advice would you give him, Marcy?
Yeah. That's a very good question. So when we built like the first IA 101 model, it covers 101 languages. And I remember, I think it was at AAAI, like I gave a talk about this and later talked to someone, and I think it was a Yoruba language, like something that I was thinking that, oh, like this is a very low resource language. And she was like, no, this would like there are like a lot more language, like this would be considered like high resource in this country. And there are like a lot of these languages that, so yeah, definitely like this is a very valid point. And when we talk about the long tail of languages, it also gets more extreme as we go forward. I would answer your questions about like what we should do, or like what are I would suggest like two things. So one, we have seen for, not exactly for these languages, but for many other languages, we have seen how effective cross-lingual transfer is. And how even for the high mid resource languages, how when you have like multiple languages in your training data, they can benefit each other done right, and they can, so it's really like from my experience for now at least, like I feel like building multilingual models would a lot of times beat building just one models for only one language. So when we think about these languages, adding them to the mix with other languages that we already have some data for, like that would hopefully benefit these. And depending on the relationship of these languages together, if they share the same script, if they have some commonalities between them, they can benefit even more. So really thinking about like what other languages can help these. And then next, really data collection. It's really not the most glamorous task, but it is one of the most effective tasks. And the nice thing about that is that we can now, with good models, we can bootstrap on that. So we don't really, maybe for English, we needed like billions, we still need like billions and billions of tokens to train the model. But as we go down the languages and as we get better models, we can maybe with a smaller set, we can train models that might be okay-ish, and then we generate synthetic data and then build a model that might be a little bit better on that. So data collection and iterative refinement of models would be another suggestion for that.
Quite interesting. I had a question about synthetic data, and I think it came out from your answer. But what do you see as the limitations for, using synthetic data for our evaluation? We currently don't have so many evaluation sets, right? And you just encouraged in your talk about these, and a lot of interest have been. A lot of people are interested in synthetic data for that. Maybe your comment on the limitations?
Yeah, I think so. I personally feel better, like if we use synthetic data for eval, I think that alone shouldn't really be the thing that we do. So like for evaluation, we need as much as a nice, correct, accurate, representative data as possible. So if we can get that with synthetic data, then we already have solved the problem because the model is generating that, right? So I would suggest if we are generating data, like eval data with a model by translation, by transformation, something, I would suggest to do some post editing, some just maybe really look at like what refining and making sure that it gets really as highest quality as possible. For training data, I think that's something that it's more flexible and definitely very useful to use synthetic data. So for a lot of there are a lot of work more recently than before that show with the current quality of the models, you can really get nice performance boost by using synthetic data on top of human data. But then there's also the caveats that, like with synthetic data, how much of if you think about like the full distribution of a language, like how much of that are you generating with your synthetic data? Like what are you excluding and how to remedy for that? So that alone by itself wouldn't also be a solution, but I think it will be like an effective step to get to better models.
Yeah, absolutely. Thank you very much, Basi. Will you be able to share with us your slides?
Yeah, definitely. I'll share it with you and feel free to share it with everyone.
Thank you. This was excellent presentation. Thank you for coming to our seminars today. This was quite an informative talk, and we are very grateful. Thank you.
Yeah, thanks for having me. It was really lovely meeting all of you, and feel free to send me an email if you have any follow-up questions.
Okay, yes.
And yeah, if anyone is coming to ACL next week, let me know and we can meet in person as well.
Oh, yeah, sure. Thank you very much, Basi, again. Yeah. Okay, so everybody, thank you for joining at this point. Since we have no more questions, I'll just end the call, and we truly appreciate you for joining this month's seminar. Bye-bye.